We do not have a quiz that goes with this set of slides, but what I want to do is give you a little bit of background so in the next set of slides we can look at finding centers of gravity in more than one direction. And in the last set of slides we looked at finding a center of gravity just in the horizontal direction, in the x direction, but you can use the same method to find center of gravity in every direction. So if you had a solid object like this book, its center of gravity would be where you might balance that book on your finger, and you could give its location in all three directions, across, up, and back and forth, X, Y, and Z. Let's say we have I don't know what this is, a bulldozer or a snowplow, and we're trying to find where is the center of gravity for this snowplow. What we can do is break it into simple geometric shapes and find the center of gravity in one direction and then in the other direction. So we'll do that right now. When you're trying to find the center of gravity in the x direction, you call that x bar. So it's x with a bar over the top of it. That's the center of gravity in the x direction. And it's the bar signifies that it's a composite of those three individual shapes. And then when you're trying to find the center of gravity in the y direction, composite of those shapes, that's called y bar. So y with a bar over the top, that's the location in the y direction. So let's look for these now. First, let's look for the center of gravity of this snowplow in the x direction. So we are looking for x bar. And I'll just give you a moment to let all this glop soak in. What we have is a weight given for each of those geometric shapes, 9 pounds, 20 pounds, and 4 pounds. And we're given, let's say we've already figured out how far it is to the center of gravity of the wedge and the big box and the small box. So we've got the weights and the distances already, and we're looking for x bar. What we're going to do is fill in this table. You'll see that this is a handy tool that you can use in any situation. So first we'll fill in the weight of the triangle, that's 9 pounds, and the distance to its center, that's 5 feet. And we'll figure out the moment. And for right now, moment what, we don't care. This is going to be useful in just a second. So 9 pounds times 5 feet gives us a moment of 45 foot-pounds for the triangle, or in the x direction. Then we'll do the same with the B. That's a big one, 20 pounds. Its center is 10 feet over. 20 times 10 is 200 foot-pounds for shape B. Then we'll fill in shape C, the little one. It weighs 4 pounds. Its center is 13 feet over. 4 times 13 is 52 foot-pounds for the small shape. So what? Well, we're looking for x bar. And we've been using this formula, moment equals force times distance. Okay, look at those three terms, moment, force, distance. We're looking for a distance. So what we need is moment and force. Well, we've got the moments right here. We'll add them all up. They add up to 297 in this case. And we've got the force, we've got the weights. We'll add them all up. They add up to 33 pounds. So we've got moment and force. We're looking for distance. Here's our moment equation. Moment equals force times distance. If you divide both sides by F and rearrange terms, you get solving for distance, you get distance equals moment over force. Or you could plug them into your favorite triangle here, and if you're looking for distance, cover that one up. You're left with moment over force. So there's the version of our moment equals force times distance equation that's going to let us solve for distance. And what have we got? A total moment of 297, there it is, divided by a total weight of 33 pounds, there it is. 297 divided by 33 equals 9 feet. X bar for our snowplow is 9 feet over from this imaginary line. Now let's look for Y bar. And by the way, let me just say a word about the imaginary lines. Some designers like to just draw an imaginary line somewhere that's out away from their object, because you never know when you're going to come along later and have something sticking out of your snowplow. You don't want that thing sticking out in some negative direction. It gets all confusing. So if you make an axis sort of out in space, it can just be reassuring that, okay, you've got some room to work with. I didn't need to do that, but I did it. All right, anyhow, we are looking for Y bar. We're looking for the center of gravity in the Y direction. So we'll start with triangle A. It weighs 9 pounds. Its distance in the Y direction is 3 feet up. And we'll fill in the other two. B weighs 20 pounds. Its distance is 4 feet up to its center. And square C weighs 4 pounds, and its center is 2 feet up. So I've filled all those in. 9 times 3 gives us a moment of 27. 20 times 4 gives us a moment of 80. 4 times 2 gives us a moment of 8. There are the moments for those three pieces when we're thinking of the Y direction. And we're using our moment equals force times distance equation. We're looking for distance, so we want to find the total moment and the total force so that we can find distance. Here are the moments, and if you add them all up, you get a total moment of 115 foot-pounds. And you need the total force. If you add these weights all up, you get a total of 33 pounds. So now we have the total moment and the total weight. Okay. And now, since we're looking for distance, let's rearrange the terms in our moment equation as we did the last time. And either using the triangle or just good old algebra and rearranging them, we'll get distance equals moment divided by force. Here's our total moment that we added up, 115 foot-pounds. There it is. Here's our total force, a weight of 33 pounds. There it is. Moment divided by force equals, and what you get is 3.48. That's the distance. That is Y bar. That is the distance from this imaginary line in the Y direction to the center of gravity of this snowplow thing. So here is what we came up with. Here's our snowplow. There's a kind of a symbol representing center of gravity. And here is where that center of gravity is located in two directions. In the X direction, it's 9 feet, and in the Y direction, it's 3.48 feet. In the next set of slides, we'll use that same method just to find the center of an area, now that we've got a handle on this method of using